Hello everyone, I am Farhad from ECC section, and in today's video we are going to talk about nodal analysis. Let's see what is nodal analysis. The node voltage method is based on the following idea. Instead of solving for circuit variables I and V of each element, we solve for a different set of parameters, node voltages in this case, which automatically satisfy KVLs. As such, we don't need to write the KVLs, which is Kirchhoff voltage laws, and only need to solve KCLs, Kirchhoff current laws. Nodal analysis is more commonly used than mesh or loop analysis or analyzing the networks. It can be used to determine the unknown node voltages of both planar and non-planar circuits. Nodal equations are usually formed by applying Kirchhoff's current law to the nodes with unknown voltages, whereas equations based on Kirchhoff's voltage law. In order to apply the nodal analysis to a circuit, the first step is to select a reference node or datum node and then assign a voltage at each of the other nodes with respect to the reference node. Let us see the procedure in nodal analysis. First, select a reference node and treat it to be at zero or ground potential, which can be written as V reference is equal to 0. Then label the nodes with unknown voltages like V1, V2, V3, and so on. At each of these nodes, mark currents in the elements as flowing away from the node. Current passing from one node to another should be noted. Form KCL equations and solve the set of simultaneous equations for the unknown voltages. We have to apply Kirchhoff's current law to form the equations and then solve them. What are nodes? Node refers to any point on a circuit where two or more circuit elements meet. For two nodes to be different, their voltages must be different. Without any further knowledge, it is easy to establish how to find a node by using Ohm's law. Ohm's law is equal to V is equal to I into R, which means current into resistance. When looking at the circuit schematics, ideal wires have a resistance of 0. Since it can be assumed that there is no change in the potential across any part of the wire, all of the wire in between any components in a circuit is considered as a part of the same node. Let us see what is nodal voltage analysis. In figure 1, uh, here we have taken two nodes, V alpha, and we have two voltages, V1 and V2, and which are connected to three resistors. And in the second figure, we can see from resistor 2 to resistor 3, we have three nodes and another node which is touching the ground, which is taken as V reference. We can name them as A, B, C, and D. Nodes with same voltage. In this circuit diagram, the voltage in the green node is same throughout. Likewise, the voltages in the blue and the red node are same throughout. Enter versus leaving current. One entering current is equal to I leaving current. Node equation is formed such that I1 and I2, the sum of I1 plus I2 is equal to I3. As you can see, I1 and I2 are entering the node, whereas I3 is exiting the node. If we move I3 to the left side of the node equation, then the node equation becomes I1 plus I2 minus I3 is equal to 0. Mesh current analysis and nodal voltage analysis. First, we have to apply Kirchhoff's current law at each node. It is important to note that we'll consider the current to move from a higher potential to a lower potential always. Current never travels from lower potential to a higher potential. Kirchhoff's current law states that the sum of the currents entering a node is equal to the sum of currents leaving the node. Whatever goes in, it comes out. So, current entering is equal to the leaving current. Even Ohm's law is often used to describe the current. Consider the current moving between nodes B and C and then try to calculate. Chosen current direction is at our discretion. Let's pick I to move from B to C. The chosen current direction is at our discretion. This means B is considered as positive and C is considered as negative. Now we have to apply Ohm's law to define the current based on nodal voltages. Here at node B, current the voltage is VB, and at node C the voltage is VC, and VB is the positive and VC is negative. So the current equation becomes, according to Ohm's law, I is equal to voltage by resistance. So I is equal to, here we have the voltage from VB to VC. So VB minus VC by the resistance here is Z. So by Z. Now let's do a problem based on nodal voltage. Let us see what is what. First, we have to identify the nodes which we have already marked, VA and VB. Then the currents which are flowing through the circuit, and I1, I2, and I3 are noted. By applying nodal analysis, the given circuit has two nodes, A and B. Node voltage is VA and the node voltage for B is VB. B is chosen as reference, so we can write VB is equal to V reference is equal to 0. So V B is equal to 0. Let us apply Kirchhoff's current law KCL at node A. We get the basic equation is I1, the total current we have to find in the circuit. So I1 plus I2 plus I3 is equal to 0. First, we have to take one loop, then another loop. So for the first loop, we have VA minus 28 by 4 plus VA minus VB by 2 plus VA minus 7 by 1 is equal to 0. After solving the equation, we get 7VA minus 56 is equal to 0. So after this, 7VA is equal to 56, then VA is equal to 56 upon 7, which is equal to 8 volts. Now, after calculating the node voltage, we even have to get the branch currents, which we have already given, which are I1, I2, and I3. Let's calculate the I1, I2, I3 values. I1 is equal to VA minus 28 by 4. We have already got the VA value, which is 8. So 8 minus 28 by 4 is equal to minus 5 amperes. Then I2. I2 is VA by 2, which is 4 amperes. And I3 is equal to VA minus 7 by 1, which is equal to 1 ampere. Let us talk about supernodes. In circuit theory, a supernode is a theoretical construct that can be used to solve a circuit. This is done by viewing a voltage source on a wire as a point source voltage in relation to the other point voltages located at various nodes in the circuit relative to a ground node assigned a zero or negative charge. Each supernode contains two nodes, one a non-reference node and another node that may be a second non-reference node or the reference node. Supernodes containing the reference node have one node voltage variable. For nodal circuit analysis, the supernode construct is only required between two non-reference nodes. Thank you so much.